Hello students and welcome back. In our previous video, we have studied what is meant by memory forensics, then why memory forensics is performed, when it is performed, then what is meant by memory dump, and next the process of memory forensics. So first step was memory acquisition and the last step was memory analysis. And in the last, we have seen one scenario of practical demonstration. So today we will be performing that practical of how memory forensics is performed. So as we have studied before, memory forensics is a powerful technique which is used in digital investigation to analyze the volatile memory of a computer system. And by examining the contents of the memory, we can uncover evidence of malicious activity or identify any security breach. So, before we begin our analysis, first we need to acquire a memory dump from the target system which is infected with the malicious software. So, first we will execute the malicious software on this virtual machine, that is the target system, and after that we will acquire memory dump. So this is the malware sample. So first we have to execute this malware sample on the virtual machine. So as you can see, different files are loaded here. So now once the malware sample is executed, we have to take the dump of this memory of the system. So for that purpose we'll be using dump it tool. So, in order to take a memory dump or for memory acquisition, there are different techniques like light memory acquisition and memory dump acquisition. So, today we will be using Dump It, which is a tool for memory acquisition to create a memory dump of our target system. So, basically, open this tool and after that, select the option Yes in order to take the dump. So, as you can see, the memory dump is acquired and it is saved to this particular location with raw dump format. So as you can see here, it is saved. So first we'll rename this. So now once done, the next step is to analyze the memory dump to get detailed information about the incident occurred. And for that purpose, we'll be using volatility framework tool. So, Volatility is a powerful open source framework which is designed specifically for memory forensic analysis. And it provides a wide range of tools and plugins for analyzing the memory dump and extracting valuable information from it. So, now we have to load our memory dump into Volatility. So, let's dive into our analysis. So, this is the Volatility framework. This is the application. So before that, the dump which we have taken on our target system, so we have to load that dump into our host machine. So this is our dump which we have taken. Now we will upload this into the volatility workbench tool. So just click here on browse image option and this is the raw dump. So open this. So first we will start by examining the processes which are running on the system during the time of memory acquisition. So for that, the command is ps list or the process list. So just click on get process list. This will give us overview of the active processes and their associated metadata. So with this command, we have to identify the malicious process, its name and its process ID. So, as we know, we have executed the malware sample. See, this is the malware sample, that is bombermania.exe, which we have executed on the target system. So now we have identified its name and process ID. So its process ID is 2788. So now we have identified the name of the process and its process ID. Next, we will see whether there are any child processes running or not. So for that purpose, we have to use volatility command, that is ps tree, and then click on run. Also, we can specify here the process ID, so it will give us a more detailed view of that for that particular process only. So we'll select here the process. So this is 2788 process ID, and now click on run. So the output here, this is the output. So it indicates that process hierarchy, where each process has a parent process ID, that is PPID. Here it is given. So PPID means parent process ID and PID means process ID. So as you can see, winlogon.exe. So this is a parent process with process ID 580. Then user i90.exe is the child process of the first process, that is winlogon, and its process ID is 3096. Then explorer.exe, it is the child process of user init. And lastly, bombermania.exe is the child process of explorer.exe, which is the malicious software, that is bombermania.exe. So, this hierarchy suggests the execution flow of the processes on the system, starting from its initialization process, that is winlogon.exe, it is the initialization process, and also user init.exe. Next, to the user interface, that is explorer.exe, and finally, a potentially malicious process, that is bombermania.exe. So, this is the hierarchy of how the process was created. So, in this case, bombermania.exe appears to be a child process of explorer.exe. And this is a common behavior for malware attempting to hide its presence by running as a subprocess of a legitimate process. So, in this case, explorer.exe, it seems to be a legitimate process. So, next we will identify the dynamic link libraries which are loaded by the malware sample. So, for that purpose, we'll be using the command, that is DLL list. So, this is the command windows.dll list. Here again, we will specify the process ID for a better view and output. So, select the process ID and then run. So, from the provided output, this output, the following DLLs are loaded into bombermania.exe process. So you can see here the process ID, then the name of the process, base means where the DLL is loaded into the memory, then size, name of the DLL file, path of the DLL file on the system, load time means the time when the DLL was loaded into the memory, and then file output. So this command, it gives us the libraries which are loaded when this particular malicious software was executed on the target system. So next we will see command line command, that is CMD line command, and for that we will specify the particular process ID. Just click on run. So this command will provide us the command line arguments which are used to launch the project process. So in this case, the command line argument indicates or suggests the path to the executable file. So which is users, then glowing star, downloads, and bombermania.exe. So this depicts that how the command was executed, where actually the malicious software is uploaded or saved. So now we'll be using handles command. This command lists the open handles for the given process. So this is the command windows.handles. Next, specify the process ID and then click on run. So as you can see the output, it provides the detailed information about the various handles opened by the bombermania.exe process, including the event files, directories, keys, and many more. So you can see here the event files are also been depicted, then the directories and keys, everything is been shown here. Also you can see here the process name, then the handle value, granted access, and name is displayed here. So with these observations, we can say that the process named bombermania.exe exhibits characteristics which are commonly associated with the malware. But for more specific results, dynamic analysis is performed, which is a part of malware analysis, which we have seen in our previous video. So, this is how memory analysis works. And in memory forensics, first the memory is acquired from the system using the tool. So, here we have used dump it tool, and then it is analyzed using specialized tools like we have used today, volatility framework. So, this was just one scenario in which we have seen how to identify if any malicious activity occurred over the system or not. So, this demonstrates us how memory forensics can uncover the indicators of compromise and the malware presence by analyzing these memory artifacts which we have collected from the target system. So, overall, we know that memory forensics is a technique which is used for investigating security incidents or identifying malicious activities on the system. So, thank you for joining me today on this journey into the depths of memory. Stay curious and keep exploring.